Okay, when we talk about vertical asymptotes, we normally talk, I can't exclude, who knows, right, like trigonometric functions and others. But when we talk, do you want to talk about, you know, let me give you a few examples. So we can have a function like this, x minus 1 over x plus 2. This one has a vertical asymptote at -2. That's a VA. We can have f of x equals tangent x, and this one has infinitely many vertical asymptotes. The first one would be, let's say, pi over 2, negative pi over 2, etc., etc. So this is another VA. We can have combination of vertical asymptotes with holes in the graph, like f of x equals x plus 1 over x minus 1 times x plus 1. So you can remove this, but that means that x equals -1 is a hole in the graph, but you cannot remove x minus 1, so x equals 1 is a vertical asymptote. So that's pretty much about it. But now, in calculus, we also have to determine, I'm not going to determine these, I'm going to just determine for this one. We have to determine the limit as x approaches -2 from the left of x minus 1 over x plus 2, and the limit as x approaches -2 from the right from x minus 1 over x plus 2. This will be complete work for a vertical asymptote. Okay, so that's the theory pretty much in a nutshell, the theory behind a vertical asymptote. Okay, now let's talk about, stop me if you have questions, anyone. Now let's talk about horizontal. Horizontal asymptotes are determined only when we determine the limit as x approaches infinity or x approaches -infinity of f of x. And only if the result is a number. If it's infinity or -infinity, no. Then we say, let's say I'm going to say this is a number lowercase a, then y equals a is a horizontal asymptote. It could be at both or just one or the other. Now the slant are specific for rational functions with degree n plus 1 over degree n. So if this is degree 7, this is degree 8. If this is degree 3, this is degree 4. Always one more at the top. And I have to use the long division or synthetic to find the slant asymptote. So let's look at an example to find the slant asymptote. Is that what you had in mind, Mark? Okay. All the others are okay? The vertical and horizontal?
Yeah, that's helpful. Thank you.
Okay. So, for example, if I have, let's say, x to the 4th plus x cubed minus 2x plus 1 divided by, if this is degree 4, this has to be degree 3. So I'm going to say x cubed plus x plus 1. So the answer must be degree 1 plus some remainder over this. This degree 1 is the slant asymptote. Whatever I get here as the quotient, that will be the slant asymptote. Why? Because at infinity or -infinity, this is a degree lower than this, so this will go to 0. That's why this is non-important. It's important because this function will not exist without this piece. So this function is this plus the remainder, whatever, but this remainder has a lower degree, and when x approaches infinity, this will approach 0, so that's why the function approaches the asymptote at infinities. So let's find the answer. to this. So I cannot use a synthetic division. Synthetic division has limited applicability. It's only when the denominator is x minus a. So I realize that the function is missing degree 2. So I have x to the fourth plus x to the third space minus 2x plus 1. I don't care if terms are missing here. It doesn't matter. As long as everything is in descending order. X cubed times what is x to the fourth? The answer is x. And now I go back and distribute x to these three terms. X to the fourth, but I subtract when I write it. I have to directly subtract. So this is negative x to the fourth. X times x is x squared, negative x squared. I cannot put it under x cubed. I cannot put that term under anything else. I have to put it here where it's missing. And x times 1 is x subtract. And this goes under this. So now these are gone. Then x cubed, I have to copy negative x squared. I have to copy negative 3x. Okay, final question. X cubed times what is x cubed? Fine. Positive 1. I distribute, subtract. 1 times x cubed, subtract. 1 times x, x, subtract. 1 times 1, 1, subtract. Negative x squared minus 4x, 0. This is the remainder. So then the division of x to the fourth plus x cubed minus 2x plus 1 over x cubed plus x plus 1 equals the quotient x plus 1, both are negative, minus x squared plus 4x, I factored out, over the divisor, x cubed plus x plus 1. Only this is the slant asymptote, y equals x plus 1. Very good question, Mark. Thank you.
Thanks for working through it.
Of course. Other questions? I know it's the end of the semester. I know you're all swamped and busy, but please make the effort. One last effort and redo all the tests with solutions. Other questions? I will stop whenever you don't have questions, and we can meet again on Thursday if that's what you want to do.
Will we do an optimization?
I'm ready. Absolutely.
Okay, so it's find the point on the line y equals 3x plus 2 that's closest to the origin.
Very good. Awesome. So we are finding the minimum distance, the closest. It means minimum distance. Okay, so when x is 0, y is 2. So 0, 2. When y is 0, I move 2. So x equals negative 2/3. So negative 2/3, 0. I want to graph it. So 0 for x, 2 for y, and negative 2/3 will be somewhere here. Good. So this is the origin, and this is the line y equals 3x plus 2. And I don't know where that point that is closest to the line is. I'm gonna say I have to picture one. It doesn't matter where you picture it. We're gonna find it, the correct one. So I'm gonna say, let's say it's here. Of course it's not, but it doesn't matter. So this is point A of x comma y, and this is the distance in question. I'm not going to call it D because it's DD and I don't want to get confused, or we get confused. I'm going to call it W. So the distance AO is W. And we know that the formula for the distance is x2 minus x1 squared, but it's 0, plus y2 minus y1 squared. That's the formula for the distance. Now, I want a function of one variable. I don't want a function of two variables. Not a problem, because I know that y is 3x plus 2. So then w now is a function of x, keeping in mind that I have x squared plus 3x plus 2, everything squared. So I want to minimize w. I will differentiate. If you want to simplify, we can continue simplifying it first, if that's what you want to do. So it's x squared plus 9x squared plus 2 times 6, so this is 12x and plus 4. So finally I get, this is 10, x squared plus 12x plus 4. And now I will differentiate, find critical numbers, set it equal to 0, study the sign, and find the minimum. So w prime will be 1 over 2 the square root of 10x squared plus 12x plus 4 times the inner function prime, 20x plus 12. We set this equal to 0, and the numerator is 0. I'll divide by 4. Watch my numbers, don't trust me. Not today anyway. So I have that A, so I divided by 4. Now I don't trust myself. I think I'm okay. So I determined that A has x negative 3/5. How do I determine y? Plug it in. So then y will be negative 9/5 and plus 2. Negative 9/5 plus 2, correct? And then this is y equals 1/2. So my claim is that this gives a minimum distance, and you could say, who cares? Show me. Nobody cares. I have to show you.
Wait a second. I don't think it's 1/2, Professor. Shouldn't that really become 5 over 2?
That's what I said. Don't trust me. So, of course, it's 10 minus 1, but the denominator is 5. Yeah, the numerator was okay, but I didn't copy the denominator. 0. Okay, thank you. So now this is positive. I will not plug in anything here. I will not waste my time. So when I plug in the numerator, when I plug 0, which is here, I get positive. So on the other side, it's a linear function, must be negative. So this is definitely the characteristic for a minimum. If they want us to determine the minimum distance, min distance, I just have to plug it in. So now I have to picture the point. Of course it's not here, it has to be a little bit lower. It's at negative 3/5, which is negative 0.6, so somewhere here, and 1/5. So this is where the actual point is. Negative 3/5, and not 1/2, but 1/5. That's right here. And the minimum, for the minimum distance, I have to plug it in. Where is my distance? Right here. So the minimum distance will be the square root of 10 times negative 3/5 squared, which is 9 over 25, and minus 12 times 3 over 5, and plus 4. So I'm just going to use my calculator. So the square root, if they ask, I don't know if they do, but so it's 90 divided by 25 minus, is this 36, I think, and divided by 5 and plus 4. Okay, I'm checking again. 90 over 25, correct. Yes, negative 36 over 5 plus 4, and enter. So I got that the minimum distance is approximately 0.63. Very nice problem. Thank you for asking that. Who was that, Gabriel?
Yeah.
Good. Very nice problem. I did put the square root. Now I check everything. Good. Next question.